Here's a take home. One major take home is that you don't need to measure all the things in the world. You can just measure a sample. And if you measure a representative sample, you can infer about your results to the larger population. So that is what stats are all about. They're not about going crazy trying to sample and census the entire world, right? You want to be smart about what you do. I came across this little quote, which says, the larger the sample size, or N, the more confident you can be that your sample mean is a good representation of the population mean. In other words, the N justifies the means. So, cheesy joke, but actually it's good for remembering. But again, I am not a big advocate of you guys going out and taking hundreds and hundreds of data sets for days on end. It's better to figure out, what do you need to represent the population? So generally, when do you need a larger sample size? You need a larger sample size when you look at your data and variation is really high in the data set, like the standard deviation is exceeding 0. So if you have a mean of 8 and your standard deviation is 8, you know, that's pretty big variation, right? So keep that in mind. That's just me talking. That's not a general rule of thumb. But more variation, more sample size is needed, okay? Also, the effect size. Like if you're looking at two things and you want to see a 50% increase, or you're not going to ever think it was valuable that you did that thing, then that's a big effect size. 50% is a big shift from one group to another. But if you're looking at a 2% increase, like a tiny little effect size, like extreme athletes and things like that, you know, a 2% increase in their speed is a big deal. So some sort of new training regimen that can increase even that tiny amount is important to them. So in that case, you will need a large sample size to show that precision of change, that small little changing amount, okay? All right, cool. So let's continue along. Here, let me go back. Here's an example. So low income CSA. CSA, some of you know, is community supported agriculture. Some communities have these where you go together and you get deliveries of organic food. And maybe you look at the number of CSAs, these options for organic food in low income neighborhoods versus high income neighborhoods. So in the first low income neighborhood you look at, you only find 1 CSA is available to community members. And you go to a high income situation, there's 3. Maybe this is a neighboring community or something. And then you go to the next, there's 0, there's 4 in the high income, 0 and 2. And then at this bottom one, oops, 1 and 8. Well, already you're starting to really see that there's a big difference here. You're probably not going to need 100 neighborhoods. You might be good with 15, as long as they're representative. They're not all from the same area, maybe they're from the region and spread out, right? So in this case, I would definitely be thinking, all right, I'm seeing a really strong trend for more access to organic food, indicating maybe food deserts, maybe unfair access, you know, all sorts of sort of social justice, environmental justice issues that could be tied in here. But again, you don't need a huge data set if your data kind of starts to look like this.